can discuss with the lab number 4. Okay, that is applications to maxima and minima of two variable expressions. Okay, to study the Python program that uses the applications of the maxima and minima of the functions of two variables, and the title series expansion, then L hospitals rule. Okay, regarding to that, we can discuss the software might be used with respect to Python Colab, Jupyter, MATLAB, whatever available tool is there that we can adopt for the same. Okay, here, what is this maxima and minima? Because in case of the engineering application, okay, in order to minimize the amount of the raw material what is to be utilized, to analyze that one, we have to make use of these analysis. Another one is that the cost of investment to reduce. This moment we can adopt the minimization application to increase the profitability in the particular raw material which are to be utilized for the production point of view. In all those applications, we can make use of the minimization and the maximization applications. Because of that reason, you need to understand that with respect to the mathematical expressions which are to be get defined in the particular expressions, those are to be get considered to make the evaluation. Okay, here the optimization of the problem, what are to be get defined with respect to the maximum values and the minimum values of the two variable functions. Then another one is to get the surface area or the value in order to optimize the solution what is to be required by defining the number of variables which are to be present. Then portfolio management, especially with respect to the financial application point of view, in order to optimize the portfolios, then which will making use of the highest possibility of getting the whatever the risk which are to be present as well as return on the same. Okay, because of that reason also this minima and maxima application to be utilized. Then Taylor series expansion. Okay, this is the approximation method of functions which are to be defined in the particular expression to get into a particular solution. Okay, that can be used with respect to the physics, engineering, and the variable scientific disciplines. Then error analysis. Here, the Taylor series are most commonly using by the adaptability of the evaluation what are to be present to make that proper estimation which are to be present in the particular expression when you are going to carry the evaluation point of view. Okay, this will help the crucial importance in the numerical analysis and the scientific computations. Then solving the differential equations. Okay, this Taylor series expressions will be used especially for solving the differential equations which are to be present. Okay, depending on the two variable, three variable. Then hospital rules. Okay, these are to be used in order to evaluate the indeterminate forms. Okay, any expression which is not possible to derive or else which will going to provide once you did the determinant evaluation, it might be 0 or it might be infinite. To solve those type of expression, we can proceed for this L hospitals rule. Okay, this is also be used in calculus and the mathematical analysis itself. Then solving the differential equations. Okay, which will help to get the simplified solution for the differential expressions which are to be involved with a particular limits. Then third one is what? Asymptotic analysis. Okay, especially these asymptotic analysis are to be used in the control engineering application in order to study the behavior of the particular functionality which is to be dependent on the particular input corresponds to that of the output. There we can make that analysis with respect to that the particular response has to be happened is itself is infinite or the 0. Okay, to do that one, we are going to make use of the number of functions itself. One is to solve, that is simpy.solve for that particular expression, which will going to provide the solution for the expression what to be defined. Then evaluation of the particular expression, simpy.evaluate f. Okay, that is EVALF, evaluate the function what's to be defined. Okay, to do that one, we are going to use this Then construction of the instant function. Okay, simplify lamb that is a defined y, that is LAMB DIFY. Okay, whatever the variable which ought to be presented. What it means, which will having to define the variable expression and its library. Then I'm going to get that particular simplification, what is to be present for the particular intent of solution itself. Okay, for this reason, you need to make use of SymPy, then NumPy, the libraries which are to be present in the particular expressions, what are to be get defined. Then limit, because the limit function is also to define the particular values. Within that values, what expressions which are to be present. For that limit expression variable value. Okay, if you define this, then you will get the limit solution itself. Now we can discuss with respect to the numerical. Okay, this is the what? The numerical what would be defined. Find maxima and minima of f of xy, x square plus y square plus 3x minus 3y plus 4. Okay, I need to define that in the expression. Okay, so that what I need to do? I need to call x variable, then y variable. I need to define the function f, whatever the expression is to be defined. We can't define here f of x comma y. We have defined only f, one variable. Then x square, then xy, then y square, then 3x, then 3y, 4. Okay, d1, that is differentiation, what is to be present. Differentiation, that is derivative with respect to the f corresponding to the x, then do it functionality. d2, derivative of f with respect to the y, do it. Then the critical point I have to evaluate. Okay, corresponds to that the expression what to be defined. Okay, because of that reason it's to be required. Then S1, the derivative of f with respect to the x corresponds to the whatever the limit value is to be get defined with respect to that variable, that is the 2. Then S3, then that is S2 and S3. Okay, correspond to that of the particular derivative what you need to carry. Then print the function value, whatever the values are to be present. I need to make the substitution to find the critical point. Okay, how we can do this? By calling the substitute which are to be required for the particular solution. So that the initial value will be taken as a 0. That is the critical points are to be taken as 0 for the particular expression y. That corresponds to that of the x. Then I need to evaluate that particular functionality itself. Then Q2 corresponds to the x, what is to be present. Then similar to that Q3. Then I need to make the evaluation of delta. Delta is equal to what? It is the variable. Okay, Q1 into Q2 minus Q3 square. Then delta of Q1. Then I will get that particular output itself. I need to print whether I can get the maximum values, whether I can get the minimum values or the saddle point. If not, the test is required to continue. So that I am using a if else if functionality. Okay, if delta is greater than 0, S1 is less than 0, then whatever the f is there, H itself is maximum value. Else if delta is greater than 0, S1 is greater than or greater than 0. Okay, this is less than 0, here greater than 0. Then the value is minimum. Then delta is less than 0. Then if whatever the values are to be present, then obviously that is itself is the what? Saddle point. Then similar to that, delta is equal to 0. Then further test is required to carry. Okay, what I need to do? I need to take that code. Okay, I have to search Google Colab. How to go to the Colab? Okay, if exiting file is there, go for open Colab. Then I need to proceed for new file. I'll go for new. Once it is get opened, kindly rename the file with proper experiment what's to be presented. Okay, I have to rename with respect to the lab number 4 because I'm executing lab number 4. First, I need to do that. Okay, lab 4 05 11 2023. Okay, I have to type the code what it should be present. This output is not required. Okay, this is my code. And then I have to execute the same. Once we did this execution, it will take a time because the connectivity is to be presented. Okay, then it will be there, then it will make that evaluation, you will get that particular output itself. Okay, this is you got to know. Okay, many of them you are doing mistake with respect to that some errors. Now I will show you that also. Print. Which will show indentation error here. What is this indentation error? These expression what you defined are not there within the limits. Okay, because of that reason you got the indentation error. What you need to do? You need to provide the particular distance what is to be required. Once it comes within that loop, then only you are going to get that output itself. If not, you can't get output. Got it? Okay. Now what I will do? Here, this D1 is there. This D I will do capital. I will run. Here. Whatever D1, D2 you have defined, that itself is wrong. So that name error, whatever the variable you have defined is itself is wrong. So that verify what you have typed, then you can proceed for the execution. Simply you should not type. Then if you did mistake, then you will get corrected here. This is how you will get the output. Okay, this is for the minimization and maximum values you are going to define. I will go for new code. Second example. Okay, this is corresponding to the Taylor series expression. Okay, the Taylor series expression values are to be get defined sin of x corresponding to the x is equal to pi by 2. Okay, the third degree term I want to evaluate. Okay, find that sin of 100. Okay, so that I need to define numpy. Okay, then matplotlib. Okay, as well as simpy, because all these things are to be get required to get the precise output. X as variable, then y is equal to sin of 1 into x. Okay, then floating point x naught is equal to float pi by 2, because pi by 2 I want for that particular value I have to evaluate. Then I need to define the expression dy, then d2y, d3y. Okay, corresponds to that expression. You will get that particular evaluation what ought to be presented for the particular expression itself. Then dy at, because the whatever the expression you are going to get with respect to that the particular y. Okay, I need to define that with respect to the x and y. Then dy at. Okay, that is with respect to the whatever y which to be presented. Okay, corresponds that it is x for the what dy. Then d2 y at. Okay, that itself is what x with respect to what dy2, that is d2y. Then d3 y at is what x corresponds to that of d3y. Then I need to get that expression. I need to define, because there will be a iterations are to be presented. Then x naught values are to be get defined. Corresponds to that x naught value, I need to make that evaluation. Okay, corresponds to that Taylor series we ought to write. that is x minus x naught divided by 2 into dy at of x naught. Then x minus x naught into, that is raised to 2 by 6 into d2y at x naught plus x minus x naught raised to 3 by 24, because all these are the what the expressions what is to be required to get your Taylor series expression itself. Okay, then print simplify. Okay, y8 is equal to lambdify corresponding to the x and y. Okay, then result to be get displayed y80 pi by 2 plus 10 into pi by 180, because I need to convert that into degree. So that print of sin 100, then result to be get displayed with respect to that particular expression. Then I need to plot the same. Okay, for that reason, x variable are to be get defined with respect to the NP corresponding to the line, that is what the minus 10 plus 10. Then plot the whatever the x variable corresponds to that the line I need to get in red color. Then another with respect to that of the green color. Then corresponds that y limits are to be get defined with respect to the what minus 3 plus 3. Then I need to show the grid and I need to show the graph. I have to run this code here. Okay, minus 10 to 10 x values. Then y value is what? Minus 3 to 3. Corresponds that we are getting the waveform. Okay, this is the what output what is to be present. Corresponds to the what the Taylor series what is to be there. Okay, another one is what? Maclaurin series. Okay, but we need to concentrate on L hospital rule. But this is also one of the method which is to be used in order to get the solution corresponds to the expression what is to be defined in the form of the series of the evaluation. Okay, here is whatever the calculation is there, sin 10 then cos 10. Okay, corresponds to the what? Sin of x then cos of x. Then same way, whatever we defined here, same code. Okay, x variable. Then instead of only one expression, okay, which is having the multiple expression. That's all. That is sin x, cos x. Then float. Then dy, d2y, d3y. Then y80. Then dy80, d2y80. Then d3y80. Okay, that itself is what? First way differential expression, second, third. Okay, corresponding that the expression you are going to derive that you will going to get the output. Then I have to convert that into in terms of degree. Then print with respect to that sin 10 plus cos 10 is equal to result. Okay, whatever the values are to be present with respect to that the particular expression what you are going to define as a function itself. That itself is what? Dot 3f. What is that dot 3f? 3 digit the function f, whatever value you are going to get that to be get displayed. Okay, then differential of f of x, then returning with respect to that the particular expression numpy sin of x plus numpy cos of x. Okay, then I need to define the x parameter values, then y parameter values, which color you want that you have to define. Then you will get that graph itself. To plot that one, plot grid, plot show. Have to run. Got it. Okay, this is the what the expression. Here, print result colon dot 3f. What is this dot 3f? Function f whose result to be get displayed after the evaluation of sin of 10 and cos of 10. Okay, here decimal value you can check here. 1.082. Now I will change this. Fine. Can you got? What is that? Dot 3f dot 5f. Now it is what? 1.08197. Hope you understood this. Okay, don't get confused with respect to that. All the code what is to be get defined. Later you can ask. Still, if you are not getting with respect to that, the particular expression what are to be get defined in the Python itself. Then later I will go for next code. Hospital rule. Okay, whenever indeterminate expressions are to be present. Okay, for that indeterminate expressions to be solved by the use of this else hospital rule. Okay, I have to go for new cell, then I have to type this code. Okay, the expression is what? The limit of x equal x tends to 0, sine of x divided by x. Okay, for these indeterminate expressions to be carried with respect to that L hospital rule. Here, this is first expression. I have taken all, not required to all. What I will do, I will use hash. You should not do like this, because I need to explain that the particular expression. Because of that reason, I am taking that as a hashtag, because I need to execute the particular example what's to be get defined. Okay, because of that reason, I'm taking that as a comment. Comment means it won't include its during execution. Okay, that is the first expression. Okay, what is this first expression? Limit x tends to 0, sine of x divided by x. I need to evaluate. What I need to do? I need to call this imply. Okay, then symbol itself is expressing the as exponential exp and sine. Okay, corresponds to that limit symbol exponential sine. Okay, especially we are taking there. Then x is equal to what? Symbol of x, because only the x parameter. I need to define limit. L is equal to limit sine of x divided by x. What is the variable? That is x. What is the limit value? 0. That I have to do it. Do it what? It is the command to get that solution itself. Okay, that is what the output. Okay, whether this is correct or not, I need to make that evaluation itself. Then what I need to do? I need to type that code. Okay, now it is to be there. Okay, then I will run this. You got output 1. Why I need to make you to get confused? This is first 4.11. Later 4.42. This is another expression. What is that another expression? Limit x tends to 1, 5x raised to 4 minus 4x square minus 1 divided by 10 minus x minus 9x cube. Okay, this is my expression. For this, I need to write this code. Okay, what is my code? Simply import x is equal to symbol, then limit that expression, do it functionality. Then I'll get that output. Minus 3 by 7. This is the output. Another code I will take, then third one I will execute. Okay, what is that third expression? Limit x tends to infinity. 1 plus 1 by x raised to x is equal to e. I have to make this expression what is to be presented. Okay, corresponds that. Then I have to write the code. Okay, from simply I have to get, then math importer inf. Okay, then later x is equal to symbol, then whatever expression, I need to display that output. I got e. Okay, this is how we need to make the solution for L hospital rule. Okay, hope you understood this. Okay, this is with respect to the what? Lab number 4. Okay, practice this Then obviously this is also be available manual, refer the same. Okay, here what is the procedure? Open Colab, online or Jupyter, make execution, then type the code as it is, what is to be presented, then save, then run the tool to get your required output.